Hello friends, welcome to Machine Design lecture. Today we will discuss one numerical on design of foot lever. So this is the question. Design a foot lever from the following data. We are given that length of the lever from center of gravity of spindle to the point of application of load is 1 meter. Maximum load on foot plate is given 800 Newton. Overhang length from nearest bearing is 100 mm. Tensile shear and crushing stresses are given 70 Newton per mm square each. So we will see now given data. L is 1 meter, so 1000 mm. P is 800 Newton. Overhang length is 100 mm. Permissible tensile, compressive and shear stresses are 70 Newton per mm square. And we are not given the relationship between width and thickness of the lever. So I suggest odd roll numbers should take B is equal to 2 times thickness and even roll numbers should take B is equal to 3 times thickness. What all we need to calculate, that is diameter of shaft and overhang shaft, dimensions of boss D2L2, dimensions of lever T and B, and width, thickness and length of the key, that is WT1 and L1. And we can see that we will be using this table for helping and solving the numericals. So students, we will be using this. Okay, these are all one by one steps. Design of shaft to find D, design of boss to find D2, L2 and L, design of overhang shaft D1, and which all formulae which we will be using, that is also tabulated here for your easy understanding. So now let us solve the sum. So friends, first step is to find diameter of the shaft. We are given with the value of effort 800 Newton and length is 1000 mm. So applied torque is 800 into 10 raised to 3 Newton mm. Resisting torque equation is pi by 16 tau dq. Let us compare both the torques. So 800 into 10 raised to 3 is equated with pi by 16 tau d cube. Tau we have substituted here 70. Rearranging the terms, the 16 will go here up and pi and 70 will be here in the denominator, and then whatever is the calculation we will be taking a cube root. So we will get diameter of shaft as 38.75 millimeter. So we will be taking round of value little more, say 40 millimeter. Second step is the boss design with empirical relations. Outer diameter of boss is 1.6 times D, which comes 64 mm. Length of boss is 1.25 times D, which comes 50 mm. And overhang length, if not given, we would be taking 2L2. But here we are given the value 100 mm. So we will be taking the same value. Next and the third step, which will be there with us, that will be to find the overhang diameter of shaft. And that will be equal to D1. And that is subjected to twisting as well as bending moment both. So twisting moment is same, 800 into 10 raised to 3. Bending moment is P into small l, which is 80 into 10 raised to 3 Newton mm. According to maximum shear stress theory, we will be using the formula of equivalent twisting moment, and we will substitute values of M and T here, and we will get the equivalent twisting moment as 804 into 10 raised to 3 Newton mm. Now resisting torque is pi by 16 tau max d1 cube. Comparing this TE with this resisting torque equation and substituting the value of TE and tau max, we will be finding D1. And it is coming 38.81 mm. Previously it was 38 point something only. But because it is overhanging shaft, we need to make its design more strong because it is getting subjected to bending moment also. So last we took diameter of shaft as 40 and here we took little larger. So we will be taking 42 mm. Fourth step is design of key. So we know that key parameters, that is WT1 and L1, and we will be using empirical relations to fix up the dimensions. Width of the key is 40 upon 4 and thickness of the key is 40 upon 6. So W is 10 mm and thickness of key is approximately equal to 7 mm, or you can take 6.67 mm. As we all know, friends, that key is subjected to single shear like this way. Single shear. So considering that shear failure, our equation of torque is tangential force into d by 2. Force is equal to area into stress. So it is equal to W into L1 into tau into d by 2, which will be the equation of torque we will be using for calculations. Substituting all the values over here, we will be finding length of the key, which is right now 57.14 mm, say 58 mm. As we know that boss and shaft get connected with the help of the key. So for easy insertion and removal, we will be taking little larger length of the key as compared to length of the boss for holding purpose. So we will be taking 15 millimeter extra. Our L2 is 50 mm. We'll be adding 15 mm. It comes 65 mm. We will use larger of the two lengths. So length of the key is 65 mm. And the last step here, that is design of lever. In design of lever, as lever is like a cantilever beam, it will be subjected to bending moment nearer to the boss. And the equation of bending moment is effort applied into effective length minus the radius of boss. We have all the values. After substituting, we get bending moment as 774.4 into 10 raised to 3 Newton mm. We will be using ZYY equation for a section modulus, which will be TB square by 6. Now I have divided the class into two batches, odd roll numbers and even. For odd roll numbers, odd numbers, we will be using B is equal to 2T. So when we substitute B is equal to 2T for odd numbers, equation of Z turns 4 by 6 T cube. When we use a sigma B equation, that is a bending stress, M upon Z, substitute the value of Z as 4 by 6 T cube and M as this. We have only one unknown over here because bending stress is known to us. So odd number students will get T as 25.50 and B is equal to 2T. So B as 26 is approximated T. So B is 52 mm. Now for even roll numbers, B is equal to 3T. So when we substitute B is equal to 3T, equation of Z turns into 3 square is 9, T square into T is T cube, and 9 by 6 T cube is the final Z for even roll numbers. And once we substitute the value of this Z and bending moment and bending stress, the only unknown is the thickness of lever. Because here breadth and thickness relationship is breadth is 3 times thickness. So comparatively here we will get thickness comparatively lesser than the B is equal to 2T, which you can see, friends, that T is 19.46, say 20 mm, and breadth is 3 times T, so it will be 60 millimeter. With this step, we have completed all 5 steps of the design of foot lever, which was very simple, and this is the end of our numerical. Thank you very much.